Hello and good evening, everyone. Today we want to look at change of subject. So we want to look at change of subject. And on change of subject, hello, good evening, everyone. And today we want to look at change of subject as a topic. So we change of subject. Let me just clean what I've written on the board because I've started the class. Yeah. Thank you for joining me. And let's just look at some things we need to take note of when we are solving change of subject. So the very first one will be some few examples, and then I'll give some assignments or questions that you can answer within 5 to 10 minutes, which will be our break, and then we'll resume and then conclude. Okay. So our topic for today. Change of subjects is our topic for today. So we want to look at the very first example. The very first example for change of subjects, okay, will be if I have 1 over k. I believe most of you have seen this. If I have 1 over k equal 1 over k1 plus 1 over k2, okay, 1 over k2 solving this will basically mean if they say you should make k1 the subject. Okay, so we have to make k1 the subject. Now look at the screen carefully. You can identify that k1 is here, and there's a bunch of fractions. Okay. Now with fractions, this equation, because of this equal sign, we say this is an equation. So we are going to solve it like how we solve our normal equations. Okay. So in so doing, it basically means that we need to identify the number of terms we have in this particular equation. So we have 1, we have 2, and then we have 3. So we have 3 terms. Now, because the denominators are all variables, what we need to do is to find the LCM. And when you have denominators being variables, the k, k1, k2 being variables, it basically means that you're going to bring all of them together because they are variables. There's no coefficient there. So we bring all of them together, which will be k, k1, k2, and then we multiply it by the number of terms we have. The number of terms we have 3. I've labeled them with the green ink. So k, k1, k2 will multiply 1 over k, and that will give you k, k1, k2, 1 over k1 plus k, k1, k2, 1 over k2. Okay? Now that we've done this is just to help us get rid of the denominators we have. Okay? It's to help us get rid of this denominator, and this denominator. Okay? So we are going to use the things in the bracket to cancel out the things, the denominators. Okay, so this will cancel the k in this. Okay, and then the k1 will cancel the k1 here, and then the k2 will cancel the k2 here. So now that we've done that, we can rewrite this. Now rewriting this, it means we have only k1, k2. 1 multiplying it will not change the value, so we can go ahead and write k1, k2, and then we have k, k2, because k1 was cancelled, and then now we have what? K, k1. Okay, so having that, now we have a normal or a simple linear equation. So we need to solve the simple linear equation. Solving this simple linear equation basically means that we need to look at what we are supposed to make the subject. And then looking at what we are supposed to make the subject, we have to make k1 the subject. So let's identify where k1 is. If k1 was just this k1 in this equation, we could have just gone ahead to get rid of this k2. But the k1, we have k1 here, and then we have k1 here. We can't just make one the subject and the other will remain in the equation. Okay? So what we'll do is that we are going to do what we call grouping like terms. Okay? Grouping like terms basically means that we should bring the common things together. So when we look at it carefully, this one and then this. Okay? So this will move to this side. Remember, it is addition. So when it goes to this side, it means we become subtraction. So we have k. We have k. Let me clean that quickly. We have k1, k2. Okay? Minus, because this one is coming, so minus and it's positive. Minus k, k1 equal k, k2. Are we okay? Now, having that, basically we have to do what we call factorization. Factorization, which was a lesson we looked at the last time. So we have to factor out. Okay? Factoring out basically means that we look at what we can have at both places. So we can have k1 here, we can have k1 here. So it means that we can bring that k1 out and then into bracket, whatever is left here, what is left here? K2 minus what? K. Okay? And then the rest of the equation comes. So with this one, we are done with our factoring out. Okay? We are done with our factoring out. Now that we've done the factoring out, bracket means multiplication. Bracket. This bracket means what? Multiplication. Okay? So it basically means that if we should get rid of this, when it goes to the other side so that we make k the subject, it's going to divide because here it means multiplication. So it basically is k equals k, k2 all over k2 minus k. Okay? Or you can actually do the old-fashioned where you have to think about the principle guiding whether it's multiplication or not. So you just divide both sides by whatever you want to get rid of. So we'll cross this out and then it will still give us the same answer. So any of these methods is acceptable. Okay? Any of the methods here is acceptable. So basically this is our answer for the very first example. If you want to copy, you have just 30 seconds to copy. 30 seconds to copy. So let's quickly copy. 30 seconds to copy. 30 seconds to copy. Okay, I think the 30 seconds is up, so I'm moving to the next slide. The next slide, we're going to take the next topic. Now, the next topic basically is similar to what we solved, okay? But there's a bit of twist to it. There's a bit of twist to it. The next question, we have 1 over r equals 1 over r1 plus what? 1 over r2. Okay? We have to make r the subject. We have to make r the subject. So making r the subject, basically, we have to identify where r is. And when we look at it closely, this is where r is. It's not the subject, okay, because it is a fraction. R is not yet a subject, okay, because it is a fraction. Are we okay? So first of all, we have to think of a way to get rid of this. Now, to do that, the first thing we need to do is to count the number of terms we have in this equation. So we have 1, 2, 3, so in all 3 terms. Okay? Now we have 3 terms, you need to go ahead and find the LCM. LCM, I told you when is a variable, all of them are variables. What you do is that you bring the variables together, so it becomes R, R1, R2. Let's close the bracket. Okay, now having this, we know our LCM. What we need to do, because we want to get rid of the denominators, what we want to do is that we need to basically multiply the LCM with each of the terms in this equation. So let's go ahead and do that. We have R, R1, R2. Then we'll have it multiplying 1 over R equal R, R1, R2, 1 over R1 plus R, R1, R2, 1 over R2. And I believe from the very first example, or the example we just concluded with, or finished with, you can actually continue from here. But let's just still do it for those who are just joining us, the benefit of those who are just joining us. Okay? So, in order to finish, we need to cancel out. So, to cancel out, we want to get rid of the denominators. That's why we need to cancel out. So, R will cancel this R in the bracket, R1 will cancel this R1 in the bracket, R2 will cancel this R2 in the bracket. Are we okay? So doing that, we can now continue to write everything else because we've actually gotten rid of the denominators. So we have R1, R2 equal, the 1 here, anything multiplied by 1 is the same thing, so we don't really need to bother about it. We only bother about it if the numerators, some of the numerators are more than 1. Let's say 2 or 3. That's when it will affect how you're going to go about this. Okay? So basically, we will have R, R2. And then we have R, R1. Now, they are saying you should make R the subject, just like the very first equation we solved. Okay, making R the subject means that we need to identify whether R is at both places or we just have only one R. Okay, when we look at this closely, we have R here and then we have R here. So it means that we would have to do something called factoring out. Okay, so factoring out will require that whatever we desire to bring out of this 2 to make it 1, we'll bring it out. So that will be R. Whatever is left here, we write it. Because when I pick R from this place, to left is what? R2. We did this lesson last week on our live class. Okay? So if you've forgotten, please go and revise. Now when we factor R from here, which is we've already done, to left it's R1. Then we have R1, R2. Okay? Now having this, we have our R here. We have our R here. Okay? And then this is what we need to get rid of. We need to get rid of this. Now this is multiplying. It's multiplication that is between them because of the bracket. So if you want to get rid of it, when it goes to the other side, it's going to be divided. Okay, so that's the first way I said you should do it. It's going to be divided. So it becomes R1, R2, all over. Let me go that way. All over. Let me write that 1 equals R. Or if this confuses you, you can do the other method, which is R2 equals R2 plus what? R1. Then you just divide both sides by what? Divide both sides by what you don't want. So which means you are getting rid of it. So this will go, this will go. So it means that now we'll have R1, R2 all over R2, R1. And then you will have R. Now when you have your equation this way, cosmetic mathematics will tell you that, oh, and we prefer writing the subject on the left hand side, so you quickly just switch it over. Once you know it is not a linear inequality, you can quickly just switch it over. So it becomes R1, R2 all over R2 plus what? R1. Now, carefully, if you have your numerators being 1, 1, 1, 1, and then you'll notice that the top variables are the same variables that will appear at the denominator, which means for the top variable, which is the numerator, are the same variables that will appear down here. So you can use this to verify your answer to see if you are doing the right thing. When we go back to the previous one, you realize that what? The top variables are the same top variables that we used up here. The only thing is that maybe the operation sign will be different. Okay? So you can use that to verify your answer. And I said using that to verify your answer basically will require you to check and see if all the numerators are actually 1. Let's move to our next example. Sorry, I didn't allow you to copy, so you have 30 seconds to copy it. So yeah, I think the 30 seconds is up. So let's take another example. Yeah, this example basically we are to look at yeah. This example basically says that given that m equals 2 and n equals 3 over 4. So that's 3. Let me clean it and write it over, okay? Yeah, 3. Find the value of m2 into brackets n minus 1, then 2 n squared minus 3m. Are we okay? Find the value of this. So this basically is a form of how do I say, change of subject and substitution is taught as one topic, because sometimes they'll give you an equation that you are supposed to change the subject of, and then they'll give you values of variables that are related to that equation, so that you can substitute it in and then find the value of what you just made the subject. Okay, but with this one, we are not being asked to make anything the subject here. Okay, because they are not even equations. Equations are what will be asked to make the subject. These are basically expressions. So you never be asked to make them the subjects. Why? How do we know that they are basically expressions? Because we don't have equal signs in them. Okay? So with this one, what we need to do is to focus on how to find the core value of this when we use BODMAS or any form of operations of mathematics to solve this. So the very first thing is very simple and straightforward. Wherever you see m, you fix in -2. Wherever you see n, you fix in 3/4. The only thing that you might struggle with is because of the fraction, the n being the fraction, and then the second one to the fraction here. Okay, so let's go ahead and look at how to solve this quickly. And to solve this, I'm going to use the blue marker for the question 1. So the question 1, we have m squared into bracket n minus 1. Okay, now we have where m equal -2 and n equal 3/4. So as I said, substitution requires you that wherever you see this substitution, especially wherever you see m, you fix in -2. Wherever you see n, you fix in 3/4. So let's go ahead and do that. And besides everything that you need, you make sure you fix it into a bracket so that you don't get confused. So I'll open my brackets, fix in -2, and I'll bring the square. There's a bracket. I have 3/4 minus what? 1. Are we okay? 3/4 minus 1. Now let's continue quickly. Now BODMAS, let me speak against this confusion. BODMAS basically is we have brackets. This is not off. Okay? This is not off. You get most teachers saying bracket off division. Please, this is not off. This is not off. BODMAS, you have brackets. The O here is order, not off. Okay? Now, the order basically means what? Squares. You do exponents, okay? So, squares. So now that we have this, a square in our expression here that we are supposed to find the value, we'll basically do the bracket first, simplify the bracket first. Now, to simplify the bracket first, we need to do a fraction, or we need to solve a fraction. So taking this is basically 3/4 minus 1. You know 1 is over 1, right? So we'll look for our LCM, which is 4. 4 going to itself once. We use that 1 to multiply this to give us 3. 1 will go here 4 times, so 1 times 4. That will give us 4. So we'll have -1/4. Okay? So -1/4. And what this means is that, you know, 4/4 is actually your whole. So if you want to do this quickly, there's also another way to do that. Once you see 1 there, you know that we have 3/4. 1. 1 is the same as 4/4. Okay? So it means that you have 1/4, but you owe 4/4. So when you pay that, you have 3/4 and you owe 4/4. So when you pay that, you still be owing 1/4. Okay? So basically you can do that if it is 1. If it is 1. So we've done that. We know our answer to be -1/4. We'll bring it closer to this side. And then now we'll come and do this. This is order, not off. Okay? It's strange to have 2 multiplications in BODMAS. So you can't say bracket of division, multiplication, addition, and subtraction. No. It is bracket, order, division, multiplication, addition, and subtraction. So it means that in your expressions that you're supposed to use operations to find the value of, if you have a square in there, right after solving for brackets, you solve the squares first before you do any division in that particular expression. That's what it means. So it means that we'll quickly, there's a square which is order. Okay, so we're going to work with that order. Working with that order basically means that we want to look at -2, okay, square. -2 square basically means that Let me explain this quickly. A times A is the same as A squared, which means that the same number should multiply itself. So in this case, we will have negative 2 times what? Negative 2. Negative multiplying negative should give us a positive answer. So we sorted out the charges with this operation. Now multiplication, 2 times 2 will give us 4. So it means that our answer should be what? 4. So having that, this answer is going to be 4. Okay, so I have moved the workings and everything on this side of the board basically because when I decide to write this way, it won't fit there, and I want more space to be able to express the reason why I'm doing most of the things. So now that we have this answer, we'll go ahead. Bracket means multiplication, so we can just quickly remove the bracket and then bring this there. Now, any number standing on its own is over 1. And the equation sign between them is multiplication. So since it's multiplication, we can cancel out. So 4 will go into itself 1, 4 will go here 1. So now we have 1 over 1 times what? Negative 1 over 1. Okay, 1 over 1 is 1. Negative 1 over 1 is what? 1. Negative 1 times negative 1 times 1 is negative 1, because positive times negative will give us what? Negative. Okay, so our answer will be negative what? 1. This is our answer. So because of space, let me just work on this side of the board. I'll just solve my number 2. I just pray it will fit. So solving that, sorry about that. So solving that, I like to check my phone to see if I'm still live, so that if I've lost connection, I'll know and then do something about it. I'll put the phone there. My house is very far. I hardly get network. When I get the network, the data runs as if it is crazy. Okay, so I don't know what's happening now. Yeah, I think I'm still online. Awesome. So Jesinate is online. Guadon, okay, Guadon is online, I think so. Let's move on to the example, the question 2. So the question 2 of this, we have n squared minus 3n. Okay, wherever we see sorry about that, my phone is distracting me. Wherever we see m negative 2, wherever we see n 3 over 4. Okay, so remember, we still have order here. Remember, order is not off in board mat. It's the O is not off in board mat. It is order. Okay, and order means squares. Good, because I want you to carry the message along so that the pollution doesn't get to your little brothers and sisters. Okay.